All right, so we are going to be graphing this function a. And when you graph it, this is how it looks on your screen. We're going to find the relative or absolute maxima. And you see that there is just one minimum and one maximum, okay? And if it's one, right, you can call it an absolute maximum. It really is a moot point at that point, right? So we just say, you know, absolute max or absolute min. Okay, so go ahead and find them, and then I'm going to call on a couple of you to give me the values here. I'll pause this for a few minutes. Okay, so what do we think? Where is our absolute max for this one? Anybody? Yeah. Yes.
0.55 for the x value and negative 0.37 for the y value.
Right. So even if the question says state the x values where they occur, I like to just put in the coordinate point, right? Or you could also say f of 0.55 equals negative 0.37. Okay, so somebody else, do you have the absolute min for me? Sami?
Negative 1.27.
Correct. Any questions on this? Okay, so I think I'm actually gonna skip that next one because I think we're pretty comfortable doing this. Let's move on to this optimization problem. Sorry? What did the y go for the x? Did it? No, it's so here it's negative 1.22 and negative 3.11. And then here it's 0.55 and negative 0.37. It could be. Okay, let's go to optimization. So when we use that root word, right? Optimus, like optimum, optimal, what does it mean? Like when I say most or best, right? This is what optimization is. So it has like a maximum, like or an extreme case understanding to it, right? Optimization is when we search for a maximum or a minimum to a physical problem. So for example, these are the problems that ask you, what is the largest area, what is the box with the largest area you can construct with this, okay? Or what can you do so that you maximize the profit? Or what can you do so that you minimize the amount of sunlight coming into a room, and so on and so forth. So those are optimization problems, okay? All right, so here is one here. And this is our first like introduction to one of these problems. The problem itself isn't challenging per se. The purpose of solving this in class is how do we approach it, and then how do we express our answers. I've said many times, here in Pre-Calc Honors, we really start a shift in our thinking where the answer to a problem isn't as important sometimes as how we got there, how we justify it, and how we express it, okay? All right, so take a look here. You can put away your calculators for a minute. Let's go over some of the stuff in here. Advertisements for a new car claim that a tank of gas will take the driver and 3 passengers about 360 miles, right? Because it also depends on the mass in the car. So about 360 miles. After researching on the internet, you find that the function for miles per tank of gas for that specific car is this, where x is the speed of the car. So x is the speed of the car in miles per hour. Do you see how I'm not just reading the problem, I'm making marks as I go along? What speed optimizes the distance the car can travel on a tank of gas? So at what speed should you be going so that you get the most distance out of a tank of gas? How far will the car travel at that optimum speed? Okay? So, this f of x, what does f of x stand for? Is that the dependent or the independent variable? It's the dependent variable. What does it stand for? Thank you. Distance, okay? Yes, it's how fast the car will go. Distance is the most technical term for it. So this is the distance per tank of gas in miles per hour. And then what's the independent variable stand for? The speed. Miles, okay? In miles. Okay, so if I want what speed optimizes the distance, right? I want maximum distance, right? So I need maximum distance. So I'm going to graph this, right? Maximum means graph. That's an extremum. So let's graph this guy. Oops. Okay, and then I'm going to graph negative 0.025 x squared plus 3.5x. So you already know this is a parabola. It's facing down. It's going to have a maximum. Okay, I see nothing, right? So we're talking about my f of x, my y values are the distance, right? And we said that a car advertises that this particular car's tank of gas will take the car about 360 miles. So that kind of gives me a ballpark figure for my y value, right? So now I could go into menu, for window settings, and I want my y value to go from 0 to, like it says 360, I'll give it a little bit more. Let's just go to like 450. I just want a clean graph, okay? All right, what about my x-axis? X stood for what? Speed. So what do you think? What's okay, so my speed is at -10, and I'm sure as heck not going to be driving maximum 10 miles an hour, right? So why don't we go from 0 to, what do you think? 100. Okay, we're not going to be driving 180. Let's go to 100 or 120 or whatever, right? So let's go to 100. Okay, so look at that. So do you see there is a maximum happening over there? All right, now if you want to see a little bit more of that, you could change it to a little bit more, right? Why don't we change this to like 200, even though we're never going to be going that fast, just so, you know, we get a better sense of what the graph looks like, okay? All right, so let's find the maximum here. So menu, 6, 3, and then we drag this over this way. We drag it over that way. Look at that. The maximum is over there. So what is that? That's 70 and 363, right? So max occurs at 70, 363. All right, so what does that mean? What's the 70 stand for?
70.
That's 70 miles per hour. Okay, so that, the optimum speed, or the speed that will optimize the distance that you drive is 70 miles an hour. Okay, so optimum speed is 70 miles per hour. At the speed the car will travel the maximum distance of 363 miles. Okay? I've got technical language, I've got units, I've got quantities. This is very mathy. Okay? Moving on from that, we're going to talk about average rate of change. Okay? Does anybody know of another word, a mathematical word for average rate of change? Slope. Slope is another word for rate of change. Okay? What is rate of change? Yeah. Right. So it's basically how fast is something changes. All right? Is something changing? So for example, take a look at this function here. At this value x1, f of x1 is right there, right? F of x1. So the value of the graph is right about there. And then by the time you get to x2, the values of the function go up a little bit and then they go back down. So the value of the function is changing. But now, ultimately, it goes from f of x1 down to f of x2. Okay, so initial and final. So now, the question is, yes, the f of x values are changing. The question is, how quickly is it changing, right? So basically, as you went over 1 unit in the x, how much did it change in the y? Okay, average rate of change, right, is the total amount of change divided by the total amount of time, or in the x value. So for example, if you were driving, you know, like from here to whatever, you drive 50 miles, right? And it takes you, I don't know, 25 minutes to get there. But what was your speed about? How many miles a minute? 50 miles, 25 minutes. How many miles a minute? 2 miles a minute. Okay, that's pretty fast. Okay? All right. So now, this is where our function was initially. This is where our function was in the very end. If I connect those 2 points with a line, through how many points is that line crossing the graph? 2. A line that crosses the graph at 2 points is called a secant line. All right, remember that because later on that's going to mean something. All right. Now, to find the average rate of change, we said it was slope, right? How do we find slope if that's rate of change? What was the formula way before? y2 minus y1 over x2 minus x1 over delta x. But now, x and y are fine, but we leave y back in algebra 2. But here in pre-calc, it's no longer x and y. It's now x and what? F of x. So instead of y2, I have f of x2 minus f of x1 over x2 minus x1. All right? So that's the only thing that changes. So now, this is our rate of change, average rate of change. And look, this is the slope m of the secant line. Okay, slope of the secant line. Does anybody know why slope has the symbol m and not s? Right, but why m and not r or y or c for change? Because it comes, so this is rate of change, changing. In Latin, change is mutare, like mutation, mutate, right? Permutation. And so that's why it has the letter M. So the next time you're on Jeopardy and that comes up, again, you got to give me on-air credit. Or at the math party, right? You have no idea how many times that was the password to even get in. Okay, so now let's find the average rate of change. Mutare. Mutare.
You already know who's actually
Okay.
Guys, that's the next
okay.
question on the test. What does that stand for?
So we're going to find the average rate of change of each function on the given interval. Okay, so what we need, okay, m is f of x2 minus f of x1 over x2 minus x1. So here is x1, here is x2. You can't switch the order there, right? So f of x2 is f of negative 1, and then f of x1 is f of negative 3. Okay. This is x1 and x2, right? So now if I want f of x2, that's f of negative 1. So I take negative 1 and I plug it into here. Negative 2 times negative 1 squared plus 4 times negative 1 plus 6. So how much? Somebody, anybody? 0. All right, what about here? 9 times 2, negative 18, minus 12, plus 6, negative 24. So now m is 0 minus negative 24 over negative 1 minus negative 3. How much? 24 over 2. 12. Okay? All right. Here, I've actually even like helped you out. You have this interval, 2 to 4, so x1 and x2. But now, where are f of x1 and f of x2? On the graph, right? So this is f of x1, and this is f of x2. So m is f of x2, which is negative 2, minus 2 over 4 minus 2. That is, okay? That's a lot of 2's. Negative 2. So that's average rate of change. Okay? Now, if you write down this formula, and then you can do these calculations in your head. So if you want to skip these and just go straight here, you know, that's totally fine. This is Precalc Honors. We do want you to be able to, you know, skip some steps. But listen, nobody gets extra credit for skipping steps, right? So if you did that and you got it wrong, then there is, you know, you just got it wrong, okay? All right. So this in its entirety will be due Friday is when I see you guys next, right? And then we're going to move on to parent functions.